Hey everyone, I'm really excited to be here at Conf42 SRE 2025. Today, I want to talk about something that's been gaining a lot of momentum, especially in the world of distributed systems, and that's edge intelligence. As more and more data is generated outside traditional data centers, like in factories, on vehicles, or in remote locations, we're seeing a shift in how we build and manage reliable systems. And that's what this talk is all about. How we can apply SRE principles to these new decentralized environments in a way that's practical, scalable, and reliable. Before we dive in, let me give you a quick intro about myself. I'm Srinivas, a senior software engineer, where I work on building systems that are designed to scale reliably and securely. My focus has been on cloud native platforms, distributed architecture, and observability. Basically, making sure things are running smoothly even as complexity grows. Over the past few years, I've started looking more closely at edge computing and what it means to bring the reliability mindset of SRE into environments that are far more unpredictable and decentralized. That's the foundation for today's session. So now that we've got that set, let's talk about what's actually driving this shift to the edge. Perfect. So, what's actually driving this shift towards edge computing? For a long time, the default approach was to send everything to the cloud, collect data from devices, send it upstream, and process it centrally and then respond. That worked when data volumes were manageable and latency wasn't a huge concern. But now we're in a world with millions of sensors, real time feedback loops, and limited bandwidth, especially in industries and or remote settings. So, what we're seeing instead is a move to process data right where it's generated, whether that's on a factory floor, inside a vehicle, or the network edge. This has massive benefits like lower latency, better responsiveness, and reduced cloud loss. But it also changes how we architect systems. We are no longer relying on centralized infrastructure and we are building intelligence into the edge. And that introduces new reliability challenges. And that's where we start thinking, how do we bring in SRE principles into these kind of environments? So now, if you've worked in SRE or reliability engineering, a lot of the core ideas like error budgets, SLOs, automation, and observability are probably familiar to you. But when we take those ideas and try to apply them to edge environments, things get a little trickier. The edge is messy. Devices might be low power, they might have limited connectivity, and they're often running in conditions we can't fully control. So we can't always expect 5 nines reliability or seamless deployments like we do in the cloud, right? That means we need to adapt SRE principles or practices to fit this particular context. For example, error budgets might need to account for connectivity gaps or power limitations. And SLOs should reflect what's realistic for each location or device type, not just a global average. And coming to automation, it still plays a huge role, but it needs to be lightweight, resilient, and designed for patchy networks. When it comes to observability, we have to rethink how we collect data because shipping logs and metrics to the cloud in real time isn't always feasible. So, overall, it's not about abandoning SRE, but it's more about reshaping it to work in the real world conditions of the edge. Great. Now, coming to the DevOps and containerization at the edge, one of the ways we've brought consistency and speed to backend systems is through this, meaning DevOps practices and containerization. And now we are extending those same ideas to the edge. But of course, edge environments have very different constraints, so we have to adapt accordingly. For starters, traditional containers can be way too heavy for edge devices. So we lean on lightweight container images using things like Alpine-based builds or even distroless containers that strip out everything you don't need. That helps reduce memory usage and startup time dramatically, sometimes over 90%. Then there's CI/CD. Edge deployments need a different approach, especially because devices may have limited bandwidth or unreliable connections. So we use more progressive rollout strategies, automated rollback mechanisms, and smart sync pipelines that can resume where they left off if the connection drops. And finally, configuration management. We still want GitOps style workflows, but tailored to the edge. That means treating device configs like version code and using tooling that can sync and enforce config states even at scale. And it should be across hundreds or maybe thousands of devices. So DevOps at the edge is absolutely possible, but it just needs to be tuned for the environments it runs in. So once we've deployed applications to the edge, how do we know they're actually working the way we expect? That's where observability comes in. But again, just like with automation, we have to rethink how we approach it for the edge. In a typical centralized setup, we might collect a ton of logs, metrics, traces, and send them all to the cloud and analyze them there in a general setup. But at the edge, that's not always practical. We might not have the bandwidth or the connection might be intermittent. So the strategy shifts. We focus on collecting the right data and doing smart aggregation locally before pushing anything upstream. For example, instead of sending every log line, we might detect anomalies at the edge and only forward summarized or critical data. Some platforms now even support lightweight anomaly detection directly on the device. So we can catch issues early without waiting for any cloud analysis. And we still aim for end-to-end visibility using distributed tracing. So we can follow requests across the edge and into the cloud. But we build it in a way that respects the resource constraints. So in short, observability at the edge is about being smart, selective, and efficient. So we stay informed without overwhelming the system. Okay, now here's where things get really interesting because we are not just collecting data at the edge anymore, we're actually running intelligence at the edge. With the help of lightweight AI models, we can now deploy logic that doesn't just react, but actually predicts and heals right on the device. A great example is predictive maintenance. Instead of waiting for a sensor to fail, edge devices can run small models that look at vibration or temperature trends, detect anomalies, and trigger alerts before something breaks. One real-world use case, a manufacturing facility reduced downtime by 37% just by deploying local models that caught early signs of machine wear. Then there's autonomous healing. Imagine a system that detects performance degradation or corrects it automatically by rerouting traffic, restarting services, or simply adjusting resource usage without any human intervention. And this is happening. We are seeing this in smart grids where devices can reconfigure power distribution paths when there's an outage, keeping critical infrastructure online. What's amazing is that these capabilities are running on resource-constrained edge hardware and not some big cloud clusters. It's a huge leap forward in reliability and a perfect complement to the kind of self-healing systems we aim for in SRE. We've talked about the why and the how, but let's take a look at what this actually looks like in the real world. There are just a few examples of industrial IoT systems that have embraced edge intelligence with really powerful outcomes. The first one comes from smart manufacturing. A major automotive company deployed edge-based analytics for real-time quality control on their assembly lines. By analyzing sensor data right on site, they were able to reduce defect rates by 23%. And at the same time, they cut down on cloud data transfer cost by nearly 80%. And coming to the oil and gas sector, remote well monitoring is a perfect edge use case. One setup was able to maintain visibility and control during a full 3-day cloud outage, avoiding any downtime that would have cost over $1 million per day. And that kind of resilience simply isn't possible without edge-first design. And in maritime logistics, where connectivity is often unreliable, edge devices on shipping containers allowed real-time tracking and monitoring, even when completely offline, ensuring end-to-end supply chain visibility possible in this use case. So what ties these together isn't just the use of edge, it's the way SRE principles were adapted to environments that are unpredictable, distributed, and often disconnected. It shows that with the right architecture and mindset, we can build highly reliable systems anywhere, even in the harshest conditions. Now, let's talk about how we actually design these edge systems to be resilient by default, especially in environments where failure isn't a matter of if, but we often say everything fails eventually. And at the edge, that's even more true. So we built with that in mind always. One of the most effective tools is circuit breaking, where a component that's struggling or unstable can be isolated before it causes a chain reaction. This helps us contain problems instead of letting them spread across the network. We also use intelligent failover mechanisms where systems can automatically switch to backup nodes or fallback services when something goes wrong. And then comes data replication. It is another big one. When devices are scattered across locations, we need to make sure that data isn't lost if one node fades. So we replicate it smartly, often in real time. And then there's mesh networking, which is super valuable in remote or mobile environments. Devices can talk to each other directly, rerouting around failed connections, forming self-healing networks that maintain uptime even when parts of the system go dark. So together, these patterns gives us a foundation for building robust edge systems that stay operational even in unpredictable conditions. Perfect. So once we have designed these edge systems for resilience, the next question is, how do we manage them at scale without losing our minds? That's where infrastructure automation becomes critical. First, we start with infrastructure as code. This lets us define edge environments declaratively, just like we would with cloud resources. We version control everything so we can repeat deployments consistently, whether it's 10 devices or 10,000 devices. Next, we bring in policy as code. Before any deployment goes live, we validate it against security, performance, and reliability rules. It's like a safety net that prevents bad configurations from going out to edge devices where rollback might be slow or impossible. And finally, we layer on GitOps. This gives us a clean, automated sync between what we have defined in Git and what's actually running in the field. If something drifts, it gets reconciled automatically. What's great about this approach is that it gives us a single source of truth and repeatable workflows, even across disconnected, resource-constrained environments. In other words, we bring the discipline and automation of cloud operations to the edge without compromising reliability or control. Okay? One of the biggest architectural decisions we face with edge systems is this: what should run locally and what should stay in the cloud? Not everything makes sense to push to the edge. Some workloads are better centralized, especially when they're compute heavy or require a global view. But for the other tasks like real-time control, anomaly detection, or basic analytics, we often can't afford the latency of cloud round trips. These are the kinds of operations that need to happen right at the source. So what this slide shows is a way to think about that balance. On the left, we have workloads, real-time decisions, anomaly detection, and basic analytics, things that benefit most from being processed at the edge. As we move to the right into things like historical analysis or machine learning, model training, those are typically still better handled in centralized cloud environments. So, successful edge architectures find the sweet spot. They combine local autonomy for fast, reliable reactions with centralized intelligence, like for learning, optimization, and visibility. This hybrid model, where we combine both, is really the key to getting the best of both worlds, which will have low latency, local action, and high level coordination and insight from the cloud. All right, let's wrap it all up with a few key takeaways. First, implementing edge intelligence isn't just about performance. It delivers real, measurable impact. On average, we have seen a 40% reduction in latency when not time-sensitive operations are processed locally. That's the difference between reacting on time and reacting too late. On the cost side, moving analytics to the edge can cut cloud data transfer by up to 65%, especially in data-heavy environments like manufacturing or logistics. And when we combine that with the proper SRE practices, customized for edge environments, we can realistically aim for 99.99% reliability, even in decentralized resource-constrained systems. So with all these key takeaways in mind, what are the next steps? Start by looking at your architecture. Identify which workloads need real-time processing and which ones can stay centralized. Then define SLOs for your edge systems. Think locally, not just globally. And finally, build in the right observability, automation, and infrastructure management so you can scale with confidence. Edge computing isn't a future trend, it's already here, and with the right mindset and tools, we can make it just as reliable as anything in the cloud. Great. Thank you so much for joining me for this session. I hope it gave you a fresh perspective on how SRE can evolve for the edge, where systems are more distributed, the stakes are higher, and the challenges are different. But remember, no less solvable. So if you're working on anything in this space or just curious about edge infrastructure, observability, or reliability, I'd love to connect and learn from your experience as well. You can scan the QR code on the slide to connect with me on LinkedIn, or you can just use the handle attached to connect with me. Thanks again for your time and enjoy the rest of the conference.